Hello, good morning friends. Welcome back to your favorite channel Code One Digest. Today in this video, I'll explain you what is non-blocking asynchronous microservices. Yes friend, you would have heard this term. It is a very trending term these days, right? Everybody wants to have their microservices non-blocking and asynchronous. What does that mean? How can you create non-blocking asynchronous microservices using Springboot? There are framework available like Node.js where you can create this non-blocking asynchronous microservices very easily. But the people like those who are very comfortable, those who are very familiar with the Spring Boot, how can they achieve the similar functionality, similar non-blocking asynchronous microservices using a Spring Boot framework? As we all know, most of these microservices we build in Spring Boot using REST controllers. Hence, we would like to know how to create our microservices as asynchronous microservices or non-blocking microservices using Spring Boot. So today I'm going to show you that. So stay till end of this video. It is going to be very informative and very exciting. There is a lot to learn in this video, friends. So stay with me till end of this video.
There's no agenda here.
So friends, here is the agenda of this video today. I know it's a little long agenda, but yes, we will cover this quickly. And by end of this video, you will be able to develop asynchronous non-blocking microservices using a Spring Boot framework. Okay, friend. So I will explain you what is asynchronous and non-blocking. First of all, let's understand that. Let's have the similar understanding. What is the meaning of asynchronous and non-blocking? Then I'll explain you what is a traditional blocking microservices and what are the problem we have with those microservices. Then I'll explain you difference between blocking and non-blocking microservices. Then what are the challenges we have with blocking microservices? Understanding non-blocking microservices and how can we build it? Understanding async annotations in Spring Boot framework. Then I'll give you a Java code implementation of non-blocking API using Spring Boot asynchronous annotations. Then we'll understand the use case of non-blocking microservices and benefits of non-blocking microservices. And later I'll summarize what we learn in this video. Okay, friends. So it is going to be very exciting and very informative. Stay with me. Stay till end of this video. Friends, before we proceed in this video, I request you to subscribe this channel to grow Code One Digest family. Friends, I am creating a lot of quality videos on programming, coding concepts, design pattern and design principles, cloud and content and technologies, but I'm not getting subscribers. I request you to like, share and subscribe this channel so that I can grow our Code One Digest family. Thank you.
Oh, I'm so excited.
Okay friends, so now before we proceed in this video, let's understand what is sequential and parallel processing. Why parallel processing is more efficient and faster than sequential processing. So in computer engineering, you would have heard about parallel processing. Okay. So we all know like parallel processing is always faster than the sequential processing. So what happens in traditional sequential processing is the program starts and then task one comes. Task one is given to the CPU for the processing. It process the task and then produce the result. Then it moves to a second task, right? And then process the second task and produce a result. So this is sequential. Unless until task one is done, task two cannot be started or completed, right? So this is what we say sequential, and this is dependent. So assume you have hundreds or thousands of tasks, then it will take long time, because if one of the tasks is taking more time, then all the tasks will get stuck and they will be processed in sequential order. Now as of today, if we see there is a revolution in hardware as well. We get quad core, octa core processors in our laptop and mobiles, right? So we have multiple processor available, but in sequential flow, it always executes only on single processor. That means we are not using our hardware, our resources efficiently. Though we have other processor available with us, but those processors are ideal because we have not used the parallel processing or multi-threading in our application. Hence, we should code our application using multi-threads and using parallel processing concepts where we can engage all those resources available. If I start 5 threads, then those 5 threads will try to acquire different CPUs, or they will be using the single CPU in a round robin fashion. So if more resources are available, more resources are given to multiple threads. If those processors are occupied with some other application, then the same processor can be used by multiple threads in round robin fashion. But ultimately, all these tasks, if we see in the parallel processing, all these tasks are executing in parallel, task 1, task 2, and task 3, and giving us a result. So obviously, this parallel processing is always faster than sequential processing. See, there are scenarios where we have to use sequential processing when the output of task 1 becomes the input to the task 2. Hence, in those scenarios, we have to go for sequential processing. But where all these tasks are independent, that they can be processed independently. So in this scenario, we should definitely make our program efficient and use the parallel processing multi-threading to perform that job quickly. With me friends, we are going to have a parallel processing using multiple threadings. Friends, just for your information, I have also created videos on Java multithreading and Springboot multithreading in past. If you want to learn how to achieve multithreading in Java, how to achieve multiple threading in Spring Boot, so go and watch this video. The link is there on your screen. You can watch this video to learn how to achieve the multithreading in Java and Spring Boot. Very simple concepts, how to create multiple threads, how to get your job done through multiple threads. I'm going to use those concepts in this video as well. So if you just want to learn how to achieve multiple threading, so go and watch these videos. These are very useful videos to create a basic understanding of multi-threading.
Wow.
Okay friends, now let's understand what is asynchronous processing, how it is different from our synchronous processing. So if you see here, process A and process B, when process A calls the process B for some input, for some results, then this thread, this particular thread, the process A is waiting for the response to come. Now this process B may be a database operation, or maybe a IO operation, or maybe a network call, where this process A thread will be keep waiting for the response to come. Once this job is done, then only process A can take, thread A can take some other task to perform. That means we are wasting the time of the thread for so long to get the response from process B. But in asynchronous, what happens is process A requests data from a process B and doesn't wait for it to complete. It continue working with other tasks available to process. And then as and when the response comes back, it accept the response and send it back to the user or do some operations. We can achieve as of today using callback features, or there are multiple ways to achieve it. But most common approach that we use as of today in asynchronous processing or asynchronous programming is callback. That means as and when the response is ready, then I'll come back and take the response or perform certain operations receiving the response. I shoot a request, then I continue with my work, and then as and when the response is ready, I'll get the response and then process it. Right, friends? So this is the difference between synchronous and asynchronous processing, where in asynchronous processing, we are not waiting. The thread is not waiting for the response to come. It can continue its working. It can continue its processing the other job, other task. Right? Obviously, this approach, asynchronous approach, is much more efficient. And in latest trending programming languages like Node.js or JavaScript frameworks, they all are based on asynchronous programming. So in this demo, the we are going to use both the approaches. That means parallel processing via multiple threading and asynchronous programming for non-blocking microservices. So I'll show you how can we do that. How can we create a non-blocking microservices using both of these concepts. That means parallel processing as well as asynchronous processing. With me friends? Okay. If you have doubt, please put your query in the comment section. I'll try to reply. Before proceeding the video, I want to make sure that you understood the concept of parallel processing and asynchronous processing, right?
Really?
Okay, friends, so now let's understand what happens in traditional blocking microservices. So the microservices or web application that we create, what happens in that? So the request comes from the user, it reaches to a servlet thread, okay? And then servlet makes a call or controller makes a call to a database to get the data. It fires a query on database and try to get the result set for your query. Now, all this time, if you see your servlet thread, this thread was blocked. It was not doing anything. It was just waiting for the response to come from the database. This query may take longer time to perform the operation. Hence, this servlet thread was waiting through that time, right? This is a very inefficient way of programming and coding. Imagine you are getting lakhs of requests every minute. So what will happen in that scenario? All those requests will pile up. Your application will slow down. The customer experience will be really, really bad. It will say your sites, your APIs is not responding, right? Because all threads are waiting in the waiting state to get data from the database. There are too many requests coming in and the processing is taking longer time because of underlying database or IO operation or network call to any other services. Hence, we have to use the non-blocking APIs so that this thread, we are not blocking the servlet thread, our controller thread or servlet thread, right? The very first thread which accepts the customer request should not be blocked. It should accept the request from the customer no matter how many requests are coming. That's where you can make your application responsive and faster. The user should not feel that its request is taking a longer time or the request is blocked. Obviously, in any application, we always have a limited number of threads. So if the number of requests are more than those threads, so those threads are going to starve. Those requests are going to wait. So we have to make sure that the servlets thread, this thread is not waiting for data to come from database. It should continue serving the customer request. How can we do that? Obviously, we are going to solve this problem using a non-blocking API concept, right? We are going to do achieve the exactly same thing there, right? So stay with me. It is going to be very informative and very interesting, friends. Okay, friends. Now let's understand again the problem with traditional blocking microservices when there are high number of requests coming in. So any web server, be it Tomcat, JBoss, Aqualogic, or any server that we use, the maximum number of threads they support is 200. That we can configure, we can increase. But again, this is a default number of threads that Tomcat can have at any point of time. As soon as we start a Tomcat server, it has 200 threads available to accept the client request at the same time, right? So it has 200 threads available in a pool. Assume your site is super duper hit and you're getting lakhs of requests every minute. That means every second you're getting more than 200 requests. That means all your threads are occupied serving the client request and even other client requests are waiting there, right? You see here, thread 1 is occupied by user 1, thread 2 is occupied by user 2 request, thread 3 is occupied by user 3 request, because all these requests are coming at the same time, exactly at the same time. So if you see, we have 200 thread is blocked by 200 user, okay, and then we have more requests at the same time. Let's say user 205, its request is waiting for thread to be free. All these threads are busy because this thread has taken the request, given it to business layer, and the same thread th1 is going to the business layer, calling the other microservices or calling the database or doing a file IO operations. So it takes time unless until these operations perform and return the data to the user. Till that time, thread 1 is completely blocked from user to getting the data from the underlying system, be it other microservices or repository layer or file IO. Okay, so if you see thread 1 is getting data from other microservices, thread 2 is blocked because of it is getting data from database, thread 3 is blocked because it is doing some IO operations. Hence, having more requests at the same time, this architecture is not going to work. It is going to slow down your application and going to hit the user experience. You have to seriously think about your architecture. This architecture is not going to work for you.
Really?
Okay, friends. So now in just previous slide, we have seen what is the problem we have when the too many requests coming at the same time, blocking microservices get blocked. All those requests get blocked, right? So what we do differently in non-blocking microservices. So what we do is we don't block our customer facing threads. So these are servlet threads or our controller threads. We don't block this customer facing thread, okay, to perform the internal operation, internal job like calling the other microservices or firing a query onto database or doing a file IO operation. What different we do here is as soon as we get a request, we come to a business layer. Then what business layer do it? It frees the thread. It doesn't block the th1 and creates a new thread. Get that job done with the help of new thread. Okay, so we have a thread pool of let's say 1,000. These are worker thread. These are not our main thread. These are our main threads. These are customer facing thread. What happens is as soon as the request reaches to business layer, we take the request and we take a thread from a thread pool and we ask that worker thread to do the job. It may be calling other microservices to get data, or it may be firing a query onto database to get data, or doing any IO operation. So my worker thread will do that work for you. But my main threads are always it just taking the request from the customer, giving it to the business layer, and business layer is assigning that work to a worker thread. That means we're not blocking customer facing threads. It's always free. As soon as the request is handed over to the worker thread, this thread is free. It is free to take the request from other user, right? Now, till then, the worker thread is performing the job. It is getting the data. And when the data is ready, it will send it back to the same user using a callback methods. So we have a callback feature where we can use that callback feature to send the response back to the same user. So if you see here, no matter how many requests are coming in here, how many users are there, the main thread job is just to take the request from all the users and give it to the worker thread. We have thousands of worker thread available to do that job, right? Isn't sound interesting? I will implement this architecture and give you a demo how this works, and we'll compare the both blocking as well as non-blocking endpoints, how it is working, what is the performance of it. So stay with me till end of this video. I'm going to give you demo of this architecture. Okay,
You're good.
okay friends, let's understand what is blocking and non-blocking microservices and what are the difference between these two microservices. So blocking API block the execution thread until a result is received, as I said, right? Non-blocking API don't wait for the response to come from the backend layer and continue serving the incoming request. Single thread serve the request end to end from controller to business layer to repository layer. Very much correct. Multiple worker threads perform the backend task. As I said, right, we have a pool of worker threads. We use those worker thread to get the job done. System become unresponsive if few hundred requests comes at the same time. System remains responsive even if the thousands of requests coming at the same time because our main threads are always free. Main thread is taking the request, giving it to the worker thread. Hence main thread is free, always free. Now, microservices written in Java, Spring Boot are by default blocking microservices. Spring Boot, Webflux, Node.js are the framework to build non-blocking microservices. But here I am showing you using the traditional Spring Boot framework, how can we achieve the similar results, similar non-blocking microservices. Also friends, I have created a video in past on Java multithreading, on Spring Boot multithreading, how to achieve multithreading in Java, how to do multithreading in Spring Boot. So if you're interested, you can go and watch those videos. How can you do the multithreading in Java and Spring Boot? The links are there on your screen. You can see that. Go and watch those videos to learn multithreading in Java and multithreading in Spring Boot. We are going to use those concepts here as well in this video. Okay friends, now let me show you Java code implementation of non-blocking microservices using Spring Boot framework, Spring Boot annotations. Friends, this code I am sharing in my GitHub repository. The link is there on the screen. You can download this project and play with it. Okay. So the repository link is also given in the description section of this video. You can download the code and run it in your local and understand how it is working. Before we move to a coding, let me explain you there are few annotations that we are going to use in our project. Okay, enable async is a class level annotation. So this annotation tells the Spring framework to run methods in a separate thread. Now let's understand what is async notation. This is a method level annotation, and this annotation tells Springboot to run this method in a separate thread, and thread will come from a predefined thread pool. Configuration. This is a class level annotation. This indicates that the class has @bean definition method. So Spring container first process the class with the @configuration annotations and get the Spring being ready to be used by other component in application. Right, friends? So we are going to use these three annotations extensively in this demo, and I just wanted to touch up on this. Let me show you the code implementation that I have done for non-blocking microservices. So friend, this is a Maven based Spring Boot project where I have a pom.xml. This is a version of Spring and I'm using Java 8 here, and nothing fancy in this pom.xml, just a basic dependency, and I'm using the Lombok for logging and out of the box getter setter facility. Let me show you how the structure look like. So I have source, main, Java, and resources folder. Inside resources, I have this application.properties. Now, this is a configuration file where I have defined where to run my microservices that is running on 8080. And this is just a test file to read or write to perform IO operation. Okay. So this is a test file location or test file that my microservice is going to read or write into this file. Now if we go and open the Java code, so here I have created two controllers. One is blocking and one is non-blocking. Why? Because I want to test the performance of both the calls when it is going via blocking controllers and when it is going through a non-blocking controller. So we'll see that. Let us open the blocking controller, and if you see, I have defined this get call where I'm getting a customer by name from the database, and it is calling this customer service, right? And then I have post call to save the customer. Then third call is to read the content of the file, and fourth call is the post call to write into a file. So these are the four operations that we have for the blocking. On the same line in non-blocking controller also I have the same operation, right? Here I am reading the customer data in get call. Here I am saving the customer data in post call, and I am reading the file and I am writing into file with get and post call respectively. Here the endpoint is non-blocking, and in blocking one here I have an endpoint as a blocking. If you see, this non-blocking controller is calling async service. That means this is a business layer class, but in blocking it is calling our customer service business layer class. Let us see that. So if we go to business layer, we have these classes. Let me show you the configuration, how the configuration look like. So this is the core of our multi-threading. We want to achieve multi-threading in this project. Hence, we have to define this configuration class where I have named it as async thread pool config. You can name as per your convenient, but we are saying that it's a configuration. That means we are creating a bean out of it, and this bean object with this name will be available in a Spring container throughout the life cycle of the Spring container. So anybody, whoever wants to access this bean, they can refer by using this name. And what we are saying is enable async. Enable async means we are enabling creating multiple thread in Spring Boot framework. Now here if you see in this method, what we are doing is we are creating a multiple threads. We are getting a thread pool ready so that our business layer can use this thread pool to get a thread from this pool and perform a task. If you see, we are using this thread pool executor and then setting the core pool size and max pool size, right? To have a number of threads ready, available before our application starts. As this is a configuration class, so this will get ready first, then our controller, business layer classes, repository layer classes will get ready. Once this is ready, then using the bean name, we can request a thread from this pool. Core pool size is 1000 and max pool size is 1000. That means 1000 threads will be created. Now let me show you first the blocking service, that is customer service. As soon as the request comes here, then it uses this repository to get the customer by name. Then add customer to save customer into repository. Same line, we have a file server which can read the file and write into a file. Now what is difference here in async service? This is our async service that we have. Now in this, if you see what we are doing here is, if you notice on this methods we are using async annotation here. Okay, so what we are saying is as soon as the request comes and this method try to execute, this method will execute into a separate worker thread. These three lines are going to be executed by worker thread. As soon as control comes to async service on this method, a new thread will get pulled from the thread pool that I shown you earlier, and this method will execute in the new thread. Same way, even saving customer is also executing in a new thread. Same way, reading a file is executing in a new thread. Same way, a writing file can be executed in a same thread. I'll show you. I am printing a thread name also, which thread is executing it. So we'll get to know because we have thousands of thread. Domain object having a domain, the customer and file data, nothing fancy over there, just repository. So here we have repository. It is connecting to MongoDB, and I have a MongoDB configuration in this configuration file. I'm connecting to my local MongoDB. Okay, friends. So now as we have seen all the classes, we have understood the form.xml configuration file, configuration classes, our controller class, service layer classes, everything. Now it's time to run and see what happens. Let me start this application. I'm running this application now. So as it is building the application, it will compile the code and run all the test cases. Once the application is up and running, then we'll hit the API for both blocking and non-blocking endpoints that we have. So we are going to hit the blocking endpoints as well as non-blocking endpoint and see the performance, what happens. Okay friends, so now application is running. Now what I'll do is, let me show you my postman. So in the postman, I have created the endpoint calls to test our blocking as well as non-blocking APIs. So if you see here, I have a blocking get customer API, then blocking add customer API is a post call, then blocking get file read and blocking file write. Same way, then I have created non-blocking where I'm doing get customer, post customer, read file and write file using non-blocking. So let me first call the blocking get customer. Okay friends, now let me hit this API and see what happens. Yeah, if you see this blocking get customer API is executed and it took around 12:37 millisecond. Now let me hit this non-blocking get customer API and see what happens. In non-blocking, it is handing over the job to worker thread and freeing it, right? So if you see, this is executed in 146 millisecond, but blocking, it's took almost 1.2 seconds, right? It's a huge difference. On the same way, let's try saving a customer using blocking API. So I'm saving this check 2. I'm saving this customer using blocking API. Let us see. So it took around 745 millisecond. Now what I'll do is I'll save the customer using non-blocking APIs. Okay. So let me go here and I'll say Jenny 2 and save this. Yes. So it is happening with the 19 millisecond in non-blocking API. Now let me read a file in blocking API. So I'm reading the same file from same location, but this is blocking API. Okay, let us see what happens. So it took 538 millisecond and I'm reading the file using non-blocking API. This is non-blocking file read. Let's see. So it is 23 millisecond. Now I'm writing into a file, okay, with a blocking API. So this content I'm going to write into a file. How much time it take? It takes around 531 millisecond. And I'm writing same content into a file using non-blocking API and it takes 49 millisecond. So you see, for every call, the blocking one, our main thread is blocked to perform the IO operation. But as the main thread hands over the task to a worker thread, then it becomes faster. And especially this is very relevant. Friends, please understand. I need your 1 minute to pay attention here. This non-blocking concept is very important when you have a reasonable size of requests coming in every second. It is not for couple of requests, 4 5 requests coming every second, but you have a scenario. Whenever you have a scenario when you are getting thousands of requests every second, millions of requests every minute, that time you should go for this approach. Otherwise, it is not going to create any advantage for you. This approach, this architecture, this use case is not for 100 to 100 requests in a minute. Okay, this approach, this solution is only for once you have lakhs of incoming requests every minute. That means thousands of requests coming in every second. So remember that when you have a high traffic coming in for the data, that time you should go for this approach. With me, I hope this is clear. Okay, friends. So now let's understand where to use non-blocking microservices. As I said, when you have too many requests coming in at the same time, whenever you are creating an application or your application is expecting too many requests every minute, every second, that time you should think of implementing non-blocking microservices. You can use it during the peak season when you see there is a rise in requests at particular festival time, during holiday time. That time you can use this APIs. Use this approach to serve more user traffic. Your application today serves 1 lakh of users every day, and you see there is going to be surge in your user base. So that time you may want to upgrade your application to use non-blocking APIs. Right, friends? Use this approach if you perceive your request traffic is increasing. As I said, right? If you see that in coming years your traffic is going to increase because as your business is growing, hence you should think of upgrading your application to use non-blocking microservices than blocking microservices.
Oh, wow. That's amazing.
Okay, friends. So now let's understand the advantage of non-blocking microservices. Right? As we saw the use case scenario where to use when to use non-blocking microservices. Right? So now let's understand the advantages of non-blocking microservices. Non-blocking microservices helps in serving too many requests coming in at the same time. So please understand when you have a scenario where you are getting too much of traffic at the same time, there is a surge in traffic at particular time. Like very basic example, we know that we all book a train ticket on IRCTC website, and there is a specific time when Tatkal reservation opens up, right? For such scenarios, consider this implementation when the too many requests are coming, too many users are coming to your site, right, to perform the operation. In such scenario, you should use this non-blocking APIs. Non-blocking microservices keeps our system responsive, right? If you remember, like 10 years ago, when we used to go to IRCTC website, it used to freeze during the Tatkal ticket booking because too many requests are coming in, too many people are flowing their requests, too many people wants to book the ticket on the website at the same time. So this solution is perfectly made for such scenario. Non-blocking microservices help in handling the sudden surge in traffic. As I said, right? When you expect there is going to be surge in a traffic at a specific time on a specific day, then you can use this approach.
Sounds
With
good,
me,
man.
friends?
Sounds good. Good plan. Good talk, all right?
Okay, friends. Now let me summarize what we learned in this video today. I explained you what is asynchronous, what is parallel processing, right? So we understood that. Then I explained you what is traditional blocking microservices, what is the problem with that, right? We also seen the difference between blocking and non-blocking microservices. Then we understood the challenges that we have with blocking microservices. Then we also understood the solution using non-blocking microservices. I explained you what all Springboot annotations that we are going to use as a part of this solution. I explained you the Java code implementation of non-blocking APIs using Springboot asynchronous annotation, right? So I've shown you the Java code for controller, service, configuration classes, repository layer classes, right? So you can use that code, you can download it from the GitHub repository and play with it. Then I also explain you the usage in which particular scenario you should use non-blocking API and also understood the advantages of non-blocking APIs. Right, friends? With me, if you like this video, so give it a thumbs up and do subscribe to our channel if you are new to the Code One Digest channel. I create a lot of quality videos on Java framework, Spring framework, container technologies, design patterns, design principles. So friends, do subscribe our channel to grow Code One Digest family.
Wow, that's amazing.
Friends, if you like this video, so give it a thumbs up and subscribe to this channel for the more interesting videos. Click on the bell icon for the latest video notifications and do not forget to share this video with all your friends and colleagues. This is very useful information for students, beginners and software engineers. I am putting a lot of efforts in creating these contents. So please help me growing the Code One Digest family. Please subscribe to Code One Digest channel for the latest programming and technology related videos. Thank you.